Hello everyone, my name is Greg, and today I prepared for you 5 questions from the latest meteorology exam in the last 30 days across all authorities. Topic for today is air masses and fronts. Question number 1. What is the relative movement of the two air masses along a cold front? Cold air pushes under a warm air mass, warm air pushes over a colder mass, cold air slides over a warm air mass, or warm air pushes under a cold air mass. Okay, so the cold front is basically a cold air mass hitting a warmer air mass. When it happens, the cold, denser air undercuts the warm air, lifting it aloft. The rising air cools down and causes cloud formation along the front. In other words, this instability creates a line of cumulonimbus clouds along the cold front, with all the significant weather associated with them, namely thunderstorms, showers, turbulence, intense gusts, or low wind shear and microbursts. So, the correct answer is answer number 1. Along a cold front, cold air pushes under a warm air mass. And this answer is correct. Question number 2. Which of the 4 figures represents the vertical cross-section of a warm occlusion? Warm air is rendered in red, cold air in light blue, and the coldest air in dark blue. Black arrows point toward the direction of migration. Occlusion or occluded front forms when cold and warm front merge. It happens because the cold front travels faster than the warm front, undercuts the warm sector, and finally catches the warm front. We have 2 types of occlusions: cold occlusion and warm occlusion. Cold occlusion forms when the cold front undercuts the warm front. It happens when the cold polar air in front of the warm front is warmer than cold polar air behind the cold front. And this situation is depicted in image number 3. Now, if the cold front means the colder, denser air in front of warm front, then it slides over it along the warm front line, forming a warm occlusion. As you can see, this situation is represented by picture number 2, where cold air in light blue rises over the coldest dark blue air. So, the correct answer is answer number 1. And this is the correct answer. Question number 3. The following sequence of clouds is observed at an airport: cirrus, cirrostratus, altostratus, nimbostratus. This is typical for anticyclonic weather, the passage of a warm front, the passage of a cold front, or the passage of a squall line. Each front has its own cloud characteristic. The example given in the question is classic warm front cloud sequence. When the warm tropical air from the warm sector slowly slides over the colder polar air, it cools down adiabatically and creates a layer of stratiform clouds. First, around 500 nautical miles from the front line, we can observe cirrus and cirrostratus clouds. Thin, translucent clouds formed entirely from ice crystals that are the first sign of an approaching warm front. As the cloud's base is getting lower, the cirrostratus thickens, forming altostratus. These clouds might be thick enough to produce continuous rain around 200 nautical miles before the front line. Closer to the front, the low-level nimbostratus clouds dominate, and they can extend for thousands of feet above the ground. So, as I mentioned before, the sequence of cirrus, cirrostratus, altostratus, and nimbostratus is typical for the passage of a warm front. Answer number 2. And this answer is also correct. Question number 4. Refer to Annex. The occurrence of freezing rain at flight level 60 is most likely in square. 3 Charlie, 2 Delta, 3 Bravo, or 2 Alpha. The freezing rain is a precipitation that we can encounter usually ahead of a warm front. It's the rain that falls from a relatively warm cloud into the very cold air mass. The drops must form in a cloud in the warm sector below the 0 degrees isotherm and fall into the colder mass in front of warm front above 0 degrees isotherm. Let's open the annex to better visualize it. Okay, so this line here represents the 0 degrees isotherm in the warm sector. And this line, on the other hand, is the 0 degrees isotherm in the cold air mass in front of the warm front. The raindrops form in the stratiform clouds here and fall in this triangular area of cold air where temperature is below 0. And this area is called the rain-ice triangle, where we most probably encounter freezing rain, if precipitation, of course, occurs. This area possesses a high risk of severe icing and is considered as the most dangerous area to fly in. So, at flight level 60, we can encounter freezing rain here in the 3 Charlie square. So let's go back to the answers. And 3 Charlie is answer number 1. And it's also a correct one. All right, so let's move to the last 5th question. An air mass is an extensive body of air within which the temperature and humidity in horizontal planes are practically uniform, a large body of air within which the temperature and humidity is uniform in horizontal and vertical planes, a large body of air with temperature and humidity constant in the vertical plane, a body of air with a volume of not more than 1,000 cubic kilometers. So, an air mass is a large body of air which, in the horizontal plane, has almost uniform temperature, moisture characteristic, and very little pressure difference above the friction layer. The properties of air masses depends on the region of origin. For example, air mass which source is the subtropical high pressure belt over the Atlantic Ocean will be moist and warm. In vertical plane, doesn't matter what kind of air mass we consider. In general, pressure, density, and humidity will decrease throughout all layers of atmosphere. Temperature will generally decrease in troposphere. However, above tropopause, the temperature lapse rate will vary considerably. Therefore, the correct answer will be answer number 1. An air mass is an extensive body of air within which the temperature and humidity in horizontal planes are practically uniform. And this one is also correct. Alright, that's all for today. Thank you very much and hopefully see you next time.